Hello class, welcome to week 2 of Python, and this week we have a little bit of a lecture, and we'll just kind of go through the things that are due for this week. And the first thing that you're going to need to do is you'll need to read chapter 1. And what I want to do in this particular lecture is I want to kind of go over some of the points in lecture 1 just to kind of reinforce the most outstanding points that you need to know about. So you'll need to read your chapter 1, obviously watch this lecture, and then you'll have some homework to do. The homework itself is in 2 parts. The first part is about 10 questions that we have in my programming lab, and as you can see, in my programming lab we have 10 different questions under homework 1 that should be just about the only thing that you should be able to see. But basically, to answer, what you can do is you can click on the question, and then you type in your answer here, and then you click submit. And if you get it correct, it'll turn green, and if not, it'll be red. And you should be able to retry it until you get it correctly. And just so that you know, also, is that sometimes there are multiple types of answers for different questions. For example, the answer for one question might be central processing unit, and it might accept the text central processing unit, or it would also accept CPU. So just kind of keep that in mind as you're working through your questions. So the first part of the homework is 50 points, and that's 10 questions in my programming lab. The other part of the homework has to do with I'll just pull it up here. The questions that we have in the book would be question number 1.9 on page 28. Those 2 questions is you'll need to save them in Python files, which is file type .py, which we'll talk a little bit about in today's lecture, and then you'll need to zip those in a folder. So say, for example, you have your Python file, .py, and then I think this week we have 2 of those, 2 files for you to submit. So what I want you to do is I want you to select them both, and then what you can do is you can send them to a zipped folder, and then name that zip folder. And obviously I don't have that up on my desktop. Let me pull that up. That way you can see, because it's pulling it over to my other monitor. Okay, so here it is. Then what you'll want to do is you'll just want to name it your first, last name, and homework 1. So, so that is that's the naming convention that you'll use. So you just right click, you select both of them, right click, send to a zipped folder, and then you name the zip folder, and then you'll upload that into Blackboard. So easy enough, shouldn't be any difficult thing to do. So let's talk a little bit about some of the concepts that we have in this week's particular chapter. The first 13 or so pages are pretty self-explanatory. If you're a CIT major, you should be pretty familiar with most of these terms. So I'm not going to cover these. I'm going to leave those for you to kind of go over yourself. And we're going to kind of pick up on is right around page 14. And one of the things that you'll need to know is how to launch Python. And so to do that, you go to your Start menu and scroll down to P for Python 3.7, and there you find a couple of things. So you've got some documentation, you've got some manuals here. You have the 32-bit or 64-bit if you installed it, regular Python interactive console, or you can open up idle. And for our purposes today, we're just going to open up idle. What idle is our integrated development environment, and we can interactively do some programs here. So we've done this in the past. Simply sends it out to the console. But for most of what this class is going to be doing, we're going to need to have actual Python files, because we're going to create multiple programs with multiple lines that take up just a little bit more than a very simple interactive type of line. And so to do that, what we do is we're going to click under File, and then we'll click a new file. And what this says is this opens up a new module. Okay, and so the first thing we want to do is we want to save that module as, and I'm just going to save it, I think on my desktop. I've got a thing called Python scripts, and we'll just call this my module. And now I know exactly where it is. So if I open up Windows Explorer, I can go to my desktop, and yes, I know I've got way too many things on my desktop, but here it is. And so you can see it's sitting right there if I need to execute it. As a matter of fact, you can see I've got another Python file here called 3x2. If I right click on it, I can edit it with idle, and it'll open that up, and it'll show me this particular script that I've created. And in this script, we have several different things. The first thing is we have a documentation line. Now, as a programmer, the most important thing to remember is when you program, you are not the only one that will look at your code. I'm going to be looking at your code. If you ever work as a programmer or a network administrator, other people will be looking at your code. So it's really, really important for you to basically put in your code the most important, anytime that you have some code, a line of code, make sure you just tell the reader what the code is doing. And so you see that I've done that. The hashtag is the way for us to do that. And the way that this works is that the parser of the Python parser, whenever it goes through and looks at this script, it ignores everything on this line that is after the little hashtag. So this is known as documentation. Basically, it says this script multiplies 3x2, and we know that it's ignored because it's in red. Okay. And so then the next line says has something that goes out to the line. It says the product of 3x2 is, and then it prints out kind of an underline line of underlined text, and then it prints out 3 times 2, and with the asterisk being the thing for being the symbol for multiplication. We can clean it up a little bit. The spacing is not terribly important here, but what I can do here is I can save this file, and then what I can do is I can click on Run, and I can run the module. Okay, and what it does is it opens up Python shell, and it executes my code right here very easily, very, very quickly. All right, so this line comes out, and all of these three lines come out, and you notice that it ignored my documentation. So in Python, we have several special characters. Of course, you already know about the parentheses, and the parentheses help us to put code in between, and are often used with functions. We also have the pound sign or the hashtag sign, which is used for comments or documentation. We also have opening and closing quotation marks, which encloses a string. And so you notice that in this particular line here, I have a string literal, which is called the product of 3x2 is, and it's enclosed by our quotation marks. Now, what happens if I were to delete one of these? And let's try to save it, and then let's run it. okay? And so I get an error, a syntax error, because it says we reached to the end of the line while scanning this string literal. So it tells me that I've got a problem with this particular line. You know that the problem is on this line because that's where the red cursor is. So what we're going to do is we'll fix this, put this back in, we'll save it again, and we'll run it again. And now it works. So that kind of gives you an idea of some of the things. There is one more type of way for you to make paragraph-based comments, and that is with our triple quotes. So this way you can make multiple line comments. See, and it still runs because everything is enclosed. Whenever you use the triple single quotes, it will put everything that's in between that. It knows that everything between the closing quotation marks will be ignored by the parser. So just so you know, that's another way to do multiple line comments. All right, kind of moving forward in your book. We do have the capability, as you know, your book shows you how to do some more complex types of math. And so, say for example, we are wanting to, say for example, we want to do some complex math. So we can use parentheses. To affect the order of operations. As we know in math, order of operations, it starts with anything in parentheses, and then after that, exponents are evaluated, and then multiplication, and then division, and then addition and subtraction. So anything with parentheses is always evaluated first. And so because anything is in parentheses first, 3 plus 3 is 6 times 2. So the answer here should be 12. Let's save it and see. And yes, indeed, actually the product of I didn't change my text here, but the product of that particular question is 12. So you can use parentheses to do some more advanced mathematical types of functions. You can also use the divided by sign, which is the /. Let's run this. Okay, and so the answer to that is 3.0. And let's try something that'll be a fraction. So here we've got a little fraction of 2.5. You may want to deal sometimes with integer math. So what you can do is you can use the double quotation mark or the double /, and that should give us integer math. So it's going to round it down to the nearest integer. So let's try that. Yep, it did. So if you're ever wanting to deal in only integers, you can use those double /, and then it'll just round it down to the nearest integer. Your book talks a little bit about programming errors, and you have 3 types of errors that are talked about in your book. One is syntax errors, and I've already shown you an example of a syntax error right here, where I deleted my quotation mark. And you can see that we have a syntax error. It says end of line while scanning the string literal. So that is the definition of a syntax error. Basically, what happens in a syntax error, it means that you have violated the syntax of the Python language, and it's not able to understand exactly what you're going to do, so it exits your program. You also have some things called runtime errors, and the types of errors that are runtime are the types that cause a program to terminate abnormally. And so it might happen if a program's running, and if the Python interpreter detects an operation that it really can't carry out, then it's going to throw what we call a runtime error. So you might have something that is an input error where you ask a user to enter something, and maybe it divides something by something, and the user enters 0. Well, we know that you can't divide anything by 0. That's a mathematical error, and that will cause an error. So let's just kind of do an example of that. Divided by 0, and let's see how unhappy things are. Yeah, so here it ran, and this is an actual runtime error, and it tells us that the file line 6 in our module, this line, print 1 divided by 0, and it tells us what the error is, that we can't divide by 0. So it tells us that the error is in line 6. So we can go back to line 6, 1, 2, 3, 4, 5, 6, and we can see, we can see the that we have that particular error. I was thinking, and I'm trying to look. There should be a way for us to put together. You can kind of modify some different ways for idle to be configured. I was kind of looking to see. You also have some custom key bindings, so just to kind of help you move through some things quicker while you are programming, and that's definitely can be helpful whenever you're programming. So also has this feature called code context, which allows you to kind of see what's going on with the code here. Yep, and so what it does is it kind of validates your code as you're going along. So that's kind of handy. All right, so the most important thing obviously is always to save. The third type of error that you're going to see is a logic error, and that would be where we don't have a syntax error, we don't have a runtime error, but maybe we've had a logic error. And so say for example we're trying to calculate and convert Fahrenheit to Celsius, and so your book gives us this little example here. Let's try this. Let's be good programmers and do this correctly, and then close it in that because it's a string, and then we're going to do print 5 divided by 9 times 35 minus 32. Okay, so we're going to save this and run it. Okay, and it gives us it gives us the answer is minus 12.5. Well, we know that that cannot be right, because we know that that 32 Celsius is about 0. I'm sorry, 32 Fahrenheit is about 0 Celsius. So we know this has to be wrong. So that tells us, even though it ran correctly, we didn't get an error, didn't get a syntax error, that we know that we have a logic error. And so to fix that, we have to just kind of check our math. So the correct formula for this is 9/5. Not 5/9. And let's run it. Okay, and so this looks a lot more. Let's see, 9/5. It's actually 5/9. 5/9 times Let's try this. Okay, yep, this is correct. So Fahrenheit 35 is about 2 degrees Celsius. And again, if we want to put it in integer math, we can do this. Yeah, and it goes basically to the closest integer. And so that is how we would fix that particular program. So this is an example of the logic error. Now your book also talks a little bit about using Turtle, and what Turtle is a graphical interface for you to be able to create graphics in your programs. And so the most important thing whenever you are programming with Turtle is that you always want to import the Turtle modules, okay, or the Turtle classes. So always start with the keyword import Turtle. And just because we're good programmers, we want to type in just say what we're. So let's do just something really, really simple. So let's do the first thing. Of course, we want to show the current location and direction of the turtle. So we're going to click on we're going to type turtle, show turtle. And what this is this is a method that that actually opens up the turtle module and the window so that we can see. And so the next thing we want to do is let's write something into Turtle. So Turtle write is the name of the method because it's actually doing something. And using that method, we're going to type in welcome to Python. So let's save this and see what happens. Okay, and you can see it ran. It opened up our graphics here, and it typed "Welcome to Python" on our screen, which is pretty darn cool. Okay, so next thing we want to do is let's do some other things. So it says we want to move the arrowhead 100 pixels forward to draw a line. So let's do turtle forward 100, and let's see what happens. Okay, so now we can see when it ran, our cursor is no longer over here, but it moved it 100 pixels forward or to the right whenever it ran. Okay. So we've got forward, we can do right. We can also change the color of the line that we're doing. So say, for example, we want to do make that line red. Type in turtle.color red and let's see what happens. Okay, now we've got the same thing going on. So it's basically what it's done is it's created a line that is now red. And there are a lot of really, really cool things that you can do. You can also use the go-to method, which your book talks about. You've got a pin up method that basically takes the pin up so that it's not marking whenever you're moving the cursor, and then pin down again. So there are a lot of really cool things that your book talks about in order to create turtle graphics, and you can certainly be creative and make some interesting interfaces with them. So as for your homework, again, you have question 1.9 and you also have question 1.17. So get those in, save them in your own Python files using the file names that I said, zip them up, and then you also have your programming or your programming lab questions. Get those turned in before the due date, and you should be in great shape. If you have any questions this week, please make certain that you let me know. I'm more than happy to help. Thanks a lot. Have a great week. Bye-bye.